Welcome back. In this video, we're going to have a look at how we can manage exponents equal to 0. Now, the rule that we have to manage this, it states that a to the power of 0 is equal to 1. Or in other words, anything to the power of 0 is simply equal to 1, with one exception being that the base here, a, cannot equal 0. Alright, with this rule in mind, let's have a look at a few examples. In example 1, we have 3 raised to the power of 0. Now, applying this rule of anything raised to the 0, with exception of the base being 0, we get a value of 1. We can simply state that 3 to the 0 is 1. Now, to verify this, we'll bring up our calculators and we'll check. We'll go 3 to the power of 0, and lo and behold, it's equal to 1. Alright. Let's go down. Example 2. X to the power of 3 to the power of 0. We can simplify this using one of our previous index laws as x to the power of 3 times 0. And that's going to be x to the power of 0. And of course, that's going to be 1. Or we can simply look at and say, well, this in here, that's not going to be 0, but this in here, it's to the power of 0, so the result will be 1. So if we go straight from here, straight over to here. So that's example 2, nice and easy. Example 3, we have x to the 0 plus y to the 0. Now in previous videos I said you couldn't mix different bases. However, given the condition that they're both raised to the power of 0, x to the 0 is going to be 1, and y to the 0 is going to be 1 as well. Therefore, this is going to yield a condition of 1 plus 1, which is simply equal to 2. So we're able to simplify example 3 out really nicely. And then finally, example 4, we've got x to the 2 times x to the negative 2 plus 1. Well, applying the index law around multiplication, we get 2 plus minus 2. Then we have a plus 1 constant at the end. This is going to simplify down to x to the power of 0 plus 1, then that becomes 1 plus 1, and finally this entire expression becomes just 2. So what you find is that using this rule here, so the exponent of 0 rule, we're able to simplify some rather complicated looking expressions down to very simplified looking results.